All right, Chapter 1, our first section of notes here. We can call this Chapter 1.1. Although, according to the book, we're going to be not really in just Section 1. We're going to be kind of jumping around here a little bit. But we are discussing earth science. Our first question is, what is earth science? And the simple answer is the study of the earth. So it's a scientific study of earth, but also the universe around it. It's really the study of everything, but we focus either on the earth or on the universe, and that's why we call it earth and space science. Earth science assumes that natural events, or what we call phenomena, can be discovered by observing it and experimenting with it, or testing it. So we have major branches of earth science. Hopefully the first branch you can see there, that first picture, it has to do with rocks. Geology is the study, origin, history, processes, and structures of the solid earth. Rocks are solid. That's what we're talking about with geology. Geo is a prefix meaning solid earth. Then you just excuse me. Then you see the next picture. Sorry, is a picture of ocean or ocean water there washing up on a beach. So oceanography is the study of Earth's oceans. Very simple. And then the next picture there, you're going to see clouds and things like that. That's called meteorology. That's the study of Earth's atmosphere. And hopefully one thing you think of that happens in our atmosphere, at least in the lowest level of the atmosphere, is weather. And that's where meteorology comes from. If you watch the weather forecast, they will refer to weathermen as meteorologists. So that's what we need to remember with weather. We've got a couple other pictures here. This first top picture is what we call a nebula, and that has to do with space. And so our next type of science is called astronomy. This is the study of the universe outside or beyond Earth, and that's what we are referring to with astronomy. Anything outside of Earth. Now, obviously, Earth is included in the universe, but we are looking at things beyond that. And the bottom picture, hopefully you can see, is a picture of dead fish, a lot of dead fish, and that as a result of some type of pollution. Environmental science is a very growing area of earth science. It's the study of the ways in which we as humans interact with our environment, and of course pollution has a very big part to do with that. I want to mention just a couple other things here in notes. But before we go much further, we're going to need to jump ahead in our notes a little bit. We're going to go past the scientific method on into scientific measurements. And the reason we're doing this is because of the activity that we want to do with what we call sample size. But we want to look at scientific measurements in kind of two different ways. And the first way that we want to look at that are in terms of our numbers and what our numbers are going to mean. So our first thing is to look at two different examples here. If you look at these two pictures, you can see one has 4 dots that are pretty close to that center bullseye but very spread out. The bottom picture has 4 dots that are very close to each other but not really that close to the bullseye. We've got two things that we're looking at here, and one is called accuracy and the other is called precision. If you're accurate, you are hitting that bullseye. Now in science, our bullseye is known as what we call the true value or the accepted value. It's what we know is true. It's what we know the numbers should be. And we know those numbers through lots and lots of scientific data and research, and also by some basic facts that we understand. So accuracy means hitting the bullseye. If we look, this top picture is accurate because all these 4 are either in that white ring or inside it. Now if we look at the bottom picture, those four shots there, 4 black dots, are not accurate, but they are precise. Precision is what we call the exactness of the measurement. It's how close those measurements are to each other. And we see here on the bottom, these 4 dots are very close to each other, so that is very precise. If we look at the top picture, though, the 4 dots are not very close to each other, so it is not precise. So we need to make sure we understand the difference. Accuracy is hitting the bullseye, precision is getting close to each other. When we look at other scientific measurements, if we look at the bullseye example, ultimately we have a problem there of what we call error. Error is how far off we are. It's an expression of the amount of imprecision or variation. Now those might be big words, but what they mean, to vary means to be off. If you're shooting baskets, you're shooting free throws, and you say that your shots are varying, it means that they're not the same every time. They're off more. And so variation, imprecision just means that the numbers are not close to each other, or they're not getting close to what we want it to. This is often referred to as percent error. And we have an equation for this, an equation that you'll need to get and write in. I didn't have it included in this notes, something we did together on the board. But when we have percent error, we have two values. One is known as the experimental value, and the other is known as the accepted value. Well, these are not difficult to understand. The experimental value comes from the experiment. This is the value that we find through our experiment that we might be running. And then we also have the accepted value, and we mentioned this already when we talked about accuracy. It's the actual value. It's the value scientifically accepted as true. It's the value that we say, this is right, and we know that it's right. One more slide that we want to cover here, and then we'll stop this video notes here. With scientific measurements, we want to look at how many trials we've ran. We want to understand how confident we are. There's something called a confidence interval, and it's the range of values for where we feel very confident or right. It's not something I'm going to go in a lot of depth in talking about. It's important in statistics, but we won't get into a confidence interval too much. But anytime you speak of an interval, you're talking about a range. It's a range of values where we're confident that we can look at those without any exceptions. Now, that's not as important. This next definition is very important. It's sample size. This is simply put how large the sample is. This is a very, very simple definition. It's how big the sample is. But if we take a larger sample size, then our results are going to more accurately reflect what the true value is. And so a bigger sample size will produce us with more accurate results, more accurate experimental data. And that's it for our first section of notes covered on our first day of class. First full day of class.